Lesson 12.1. Define and use sequences and series. A sequence is a function whose domains are integers, which means x can't be anything that's not an integer. There's no fraction or decimal parts. If you'd like, a sequence is just a list of numbers that follow a rule, such as 2, 4, 6, 8, 10. So it's the rule, oh wait, they're all even numbers. Or we're adding by 2 to get the next number. That would be an example of a finite sequence. It ends. Or this one has the ellipses at the end, which means it continues forever, which means it'd be infinite. To find the rule is like a sub n equals 2n. Notice this little n is lower. The domain is n, that's like the x, that's the term's location. First, second, third, fourth, so it's 1, 2, 3, 4. The range is an, that's like y, and that's the value, 2, 4, 6, 8, or whatever the values are. So how do you write rules for sequences? You look for patterns, and then you guess and check. For example, 2 fifths, 2 25ths, 2 1/25ths, 2 6/25ths, and so on. So if we look at that and we say, hey, this looks like 2 over 5 to the first, 2 over 5 squared, 2 over 5 cubed, 2 over 5 to the fourth, because the bottoms, the denominators, are all powers of 5. And then you have to decide, how does a 1 turn into 2 over 5 to the first? How does a 2 turn into 2 over 5 to the second? It's a 3, a 4. And you say, oh, hey, wait. They all have the 2 over 5, but then the exponent is the same as the 1, 2, 3, 4. That 1, 2, 3, 4, those are the n's. So it's 2 over 5 to the n. Let's try another. 3, 5, 7, 9. Well, it looks like we're adding 2, but that may or may not help us. Let's look and see. So we add 2, we add 2, we add 2. So what this looks like, it's the 3 plus 2 some number of times. So to get the 3, it's just the 3 plus 0 times 2. To get the 5 would be 3 plus 1 times 2. To get the 7 would be 3 plus 2 times 2. See, we had the 2 twice. To get to the 9 would be 3 plus 3 times 2. So to get the first one, the only thing changing is this part in the middle, the 0, 1, 2, 3. And if I go 1, 2, 3, 4, first term, second term, third, fourth, that's 1 less than the value of n. Oh, I like the way I did it better than I did over here. Ignore that. So this appears to be, well, we'll need that. This appears to be 3 plus n minus 1 times 2. If we distribute, that'd be 3 plus 2n minus 2, or 2n plus 1. To graph a sequence, n is like x, n is like y. The graphs will be dots, though, because we can't have decimal portions of n. N has to be 1, 2, 3, 4, or 0, 1, 2, 3, 4. Do not connect your dots, because then you'd be saying there's fractional parts. So your graph would look like that, just a bunch of dots.